Okay, sir, I
So
have started the recording.
Yes, now you can ask question.
so you are told to find about the terms which appear in the classifier output.
Yes.
So the first one was mean absolute error.
Okay.
So mean
Just
absolute
a minute.
error.
Just a minute.
Yes.
Before that, if you have any doubt, you can ask me. If no doubt, then you can go for these terms, all these terms. No problem. Kshitij, do you have any doubt?
No, sir, not at this moment.
Okay, fine. Ameya, do you have any doubt?
No, sir. No, sir. I don't
Fine.
have
Then
any doubt.
go ahead. Go ahead. Go ahead. Go ahead with the segment.
Yes, sir. Sir, mean absolute error is the
If you have any files, you
summation.
can. If you have any files or notes or anything, you can share it here, so it will be useful.
Sir, actually, I've written it.
Oh, okay, fine. Go ahead.
Sir, so mean absolute error is the summation of the difference between actual and absolute value of the actual and predicted values divided
Mm-hmm.
upon the total number of observations. That is the mean absolute error.
Okay.
Then root mean squared error is the absolute difference of uh, the predicted and actual values, and it is squared, and it is the sum is taken for all the observations, and it is divided by the number of observations, and the root is taken for the entire term.
Correct.
Then relate absolute, like it has the formula summation of predicted minus actual upon
Mm-hmm.
summation of mean minus actual.
Okay.
And root relative squared error is the root of a summation of predicted minus actual square upon summation of mean minus actual square. That is
Oh,
root relative squared.
yes. Correct.
Uh, then uh, then TP rate. So there is
So it
basically
is
this
true
confusion
positive.
matrix. Sorry, sir.
So it is true positive
Yes,
rate.
true
Short,
positive rate,
long
right.
form.
It is,
Yeah.
yes, it is true positive rate.
Sir,
So
I
there
have
is
actually
this,
prepared a document, so should I share it here?
Yes, yes. Please go ahead. Please go ahead. That will be helpful. Then Ameya will just explain whatever. I mean, he will discuss whatever he has, um, studied. Till that, you can share your document. Ameya, you go ahead.
yes, sir. So then TP rate is true positive rate. So basically there is this confusion matrix
Yes.
of 2 by like n by n, where n is
Two
the
by two.
number
Yeah.
of possible outcomes. Sorry,
Yes.
yes, 2 by 2, wherein there are four categories: true positive, false negative, false positive, and true negative. And the the columns represent the predicted, and the rows represent the actual. So when
Yes.
the predicted is true and actual is also true, it is called true positive. Uh,
Yes.
when the
So we can say
when the
union of
predicted is
both.
false, yeah, yes, union of both, right? Yes, sir.
Yeah.
And when predicted, basically true or false depends upon uh, the predicted values. Like if
Yes.
predicted is false,
Actual
then
outcomes and the classified outcome.
Yes. Yes. Yes.
So if the classified outcome is the same as the actual one, then it will be true positive. If
Correct.
the actual one is different but it is classified like some other one, it will be false positive.
False positive. Yeah.
And if it is not classified, but it was the actual one, then it will be false negative. And
Yeah.
if the commodity was not there and it was not classified, then it will be true negative.
Yes. Now I remembered your question, Kshitij. You forgot afterwards. You had asked me that since there are 50 samples which we have collected for all the classes,
Yes,
how
sir.
can be sample from class A will be misclassified as B? Do you remember you had asked this
Yes, sir.
question?
Yes, sir. Yes, sir, I remember.
Now I remembered that question. See, the thing is the data which we acquire for various classes will be
Yes, sir.
treated as training data. But
Okay.
if characteristics of one of the classes matches with the another class, then there is a possibility of misclassification. Have you understood what I said? If characteristics of or statistical parameters of class A matches with class B, then it will be misclassified,
Okay.
isn't it?
So,
Because while
sir, here we were using the same data for training as well as for test. That's why we got
testing,
these results, right?
no, might not. No, actually, it is not the case. It may happen that when you are gathering the test data separately, there also that characteristics of that particular test data might matches with the another class. That is why it may misclassify.
Okay.
If you're like why do this happens, because there might be error while gathering the data for various classes. If you don't filter out the data, or if your parameter fails to differentiate between various conditions of cutting tool, if so, like we will take one example. If your tool is failed with flank wear and notch wear, so the vibration evolved because of flank wear and notch wear. If they are same, then there might be a situation where these classes will be misclassified. So that means many times the parameter which are acquiring may not be useful. It may lead to false classification. Then you might go for acquiring the noise. So noise evolved
Okay.
during the tool is failed with flank wear and notch wear, you may get the good result, because noise created during these two failures might be different, but vibration
Yes,
may
sir.
not. Or the signal processing technique which you are using, like time domain graph, frequency domain graph, or even statistical features, may not be efficient to differentiate between two conditions. It may be like that the characteristics of that particular vibration may not be defined by, or may not be, we can say, described by the signal processing techniques or these parameters. That is why it will be misclassified. So it depends on which parameter you are acquiring, the data for which parameter, like the parameter for which your data is acquiring, or you are going to map it with the tool condition, or maybe efficient signal processing technique, or efficient statistical parameters, and like that. So all these factors will define the performance of confusion matrix, or we can say define the performance of trained model. I hope my answer is fine. I mean, have you understood
Yes,
what
sir.
I said?
Yes, sir, I got it.
Yeah, because what happens is while while when you are training the algorithm will be trained with respect to the sequence which you have given in the training data. If you give classes as A, B, C, D, like A is good condition, B is failure 1, C is failure 2, and like that, then obviously it will go with the sequence by which you have presented the data. If you change the sequence, there may be different result. Are you getting what I'm saying? If you interchange the positions of samples, as
Yes,
if you
sir.
keep good condition as the last condition, then you might get the different result. Like the misclassification will be different. For A, it will be shown B, or B will be shown as A, depending on the sequence which is given there. So you can play with this particular approach. Like if you can interchange the locations of various classes within the training data, and then you just try to observe the performance of confusion matrix.
Sir, one more doubt I had.
Yeah, yeah.
Sir, so for example, if we keep the same order, like
uh,
good first and then flankware and then respectively,
mm,
and then run the same model with the same conditions two times, then will we get the exact same misclassifications?
yes.
Okay.
If your training data is same,
Yes, sir.
then you run it for number of times, you will get same results, na? Because
Okay,
there is
so
no
even
change.
if we change one condition, then the results will change.
Yes, if you remove any one condition, then the result might change.
Okay.
If there is no misclassification, see, try to understand. If in condition number 6, hmm, if there is
Yes,
no
sir.
misclassification, then your performance may not change. But if there is misclassification with other classes, then it might change. If there is no
Okay.
misclassification, there is no change, na?
Right.
Because it will have distinct characteristics or behavior.
Yes, sir.
So there won't be any change. If it has some misclassification, then definitely the model result will change.
Okay.
Yeah. Go ahead. So true positive, false positive, true negative, and false negative is done.
Yes, sir.
Then precision.
Precision is the truly classified X divided by all the classified as X.
Ameya, do you have any other definition for
Uh,
precision?
sir, precision.
Yeah. Basically, true positive rate and
Sir,
recall is same. Okay.
Yes, sir.
Precision. Yes, precision.
sir, ratio of values predicted positive that that were actually positive. That is true positive that is true positive over total predicted positive. That
Correct.
is
True positive
P
plus false
upon
positive.
TP plus FP.
Yeah. Yeah.
Yeah.
Correct. Next. F major.
F measure is the combined quantity of precision and recall. So it is
Yeah.
the harmonic mean of them.
Correct. So 2 into precision into recall divided by summation of precision and recall.
Yes, sir.
Okay. Go ahead. MCC.
MCC is
Matthew.
the Matthews correlation coefficient.
Yeah.
So it has
So
this formula.
try to understand the meaning which you have written there. Formula is not important. Meaning is
Yes,
important. Interpretation is important. So it is a correlation coefficient
between
between the
observed and
observed and
predicted
binary
binary
classification.
classification. So if we get it is between -1 and +1.
Plus one.
So
Yeah.
if we get +1, then it would be a perfect prediction.
Hmm.
0 would be a random prediction, and
Yeah.
-1 would indicate that it will be
Misclass.
total disagreement, misclassification.
Yeah. Yeah. Correct. Do you want to add any point, Ameya?
Uh, uh, no, sir. Uh,
Okay.
no, I just yes, just found the formula and that's it, right?
Okay. Fine. ROC then.
ROC is the receiver operating characteristic.
Mm-hmm.
Uh,
So that is
it is
basically,
a plot between TPR and FPR.
yeah, true positive and false positive.
Yes, sir.
So area under
So
curve will give you,
area under the curve, when it will be 1, we will say that it is perfectly distinguishable, means
yeah,
the precision is 1.
correct.
And when it is a number between 0 and 1, then that would be the percentage chance. Like if it is 0.7, it would be 70% chance that it will be able to distinguish.
Yeah, correct, correct.
When it is 0.5, it will not be able to distinguish between positive and negative.
Yeah,
And when it is 0, it will classify positive as negative and negative as positive.
that's positive. Correct, correct, correct.
Then PRC is similar to ROC, but it is a graph between precision and recall.
Yes,
Yes, sir, that's it. I've done this much.
that's it. Fine. Fine. Do you have anything, Ameya? Anything different?
Uh,
I didn't
uh,
see kappa statistics anywhere. You might have seen this term, right? Kappa statistics.
no, sir.
Yes, sir.
I didn't.
Yes, sir. It was there in the summary, but I missed it. I'll find it. Find the meaning of the kappa statistic.
Yeah, yeah, yeah. See, if kappa statistic is the value of kappa statistic, if it is near to 1, then it indicates the perfect agreement, or we can say classification. Whereas 0 indicates there is misclassification, like that only. But try to find out its meaning.
Yes, sir.
Yeah. So now just open the Weka and share it here and upload our file. Anyone of you can do it.
Okay, sir. I'll do it.
Hmm.
So I'll just open Weka and upload the file and then share the screen.
Yes, yes, no problem.
Hello, sir. I have joined the meet right now.
Okay. Aditya, right?
Yes, sir.
Yes, yes, yes. Welcome.
Sir, can you see the screen?
Yes, now I can see the screen.
Okay.
Okay, have you uploaded the file
Oh, yes, sir. Sir, I've started it also.
by J48?
Yeah. Oh, sorry. Sorry.
No, there is some.
Yeah. The classifier is I've chosen the default. Just a minute, sir. Yes, sir. Now it's fine.
Hmm. Okay, so now I may just go to pre-process.
Okay. Uh,
Pre-process.
Pre-process.
Yeah, classifier शेजारी है.
Acha.
Hmm. So now here, uh, do one thing. Keep that standard error alone. Delete all other features. Select median, mode, standard deviation, and everything. Only keep standard error and condition, because we need that class. With
Okay.
respect to, we have to classify the standard error. Fine. Okay,
Okay.
now go to classify.
Yes.
Amey, I hope you are doing. Sorry, Kshitij, I hope you are doing it.
Yes, sir. Sir, in this case, is there some problem with the classification because there are a lot of question marks and
I don't
something
know
different
what
has happened here?
Amey has done. I don't know what Amey
Sir,
has done.
can I just redo it? I'll
Yeah,
just
yeah, yeah.
close.
Please close or close everything. And Kshitij, I hope you didn't get this right. You
No,
might
sir, I
not.
did not get that.
Yeah, exactly. There is some. I don't know what happened.
Some error maybe.
Yeah. I think he might have selected some other condition. तू डेटा चेंज केला नाही आहे ना रे अमेय?
नाही सर नाही.
हा क्लासिफायला जा.
J48 folds and
Yeah,
start.
same.
Now it's fine.
Yes, now it is correct. Yeah. So now go to pre-process. Only keep standard error and delete all other features. Only keep condition. What is accuracy by J48? Kshitiz?
So the accuracy is 1 minute.
Yeah, go to classify. Ameya.
Oh yes sir.
89.66%.
Yes. So now what you have to do is you have to open the Excel sheet.
Yes.
Say start. Ameya, say start.
Yes, okay sir. Fine.
No. J48
okay,
start.
Fine.
Yeah. How much is the accuracy? Check it.
66%.
Yeah. So now open Excel sheet.
Okay sir.
Open Excel sheet. New open sheet, new Excel sheet. Open.
Okay sir.
Don't open that. Yeah, new Excel sheet.
Okay.
We will plot all these results. We will write all these results and then we will see effect of number of features. What I'm teaching you today is called as effect of number of features on classification accuracy. Okay.
Okay.
Yes sir.
So now so now write a standard error. Yeah. And in front of that write accuracy. How much is the accuracy? Yeah. I mean, write the value of accuracy directly.
Okay sir.
किती आला रे क्षितिज? 66 point. How much it is? How much is the accuracy? Kshitij?
66.33 sir.
Yeah, just write it there.
Yes.
Okay, now go to Weka again. Aditya, Weka नसेल ना तुझ्याकडे?
नाही सर, नाही आहे.
नेक्स्ट टाइम ठीक आहे, ऑब्झर्व कर
करतो
सध्या.
इन्स्टॉल.
पण आय होप तू ते हे बघितलं असेल पहिला व्हिडिओ आमचा.
हो सर, पाहिलाय.
हा, सो तुला काही गोष्टी कळत असतील आता आम्ही काय करतोय.
हो सर, थोडं कळतंय.
हा ठीक आहे. जस्ट कीप ऑब्झर्विंग. तुला काही असेल तर डाऊट तर नंतर विचार. आम्ही अगेन वी हॅव टू गो टू प्री प्रोसेस. We have to upload the Excel file again because now we have to select the other feature.
Okay sir.
Yeah, so do it now. Yeah,
And
so now we have to keep
median and condition we remove all.
median. Just keep median, delete everything. Yeah. So
And
what we are doing is we are examining the effect of each feature. Each individual feature on classification accuracy. Remove. Yeah. Classify. J48 start. Yeah. How much is the accuracy?
65.33.
Write it there. So this means that if we select only one feature and if we try to classify all the classes with respect to that particular feature individually, then what is the classification accuracy that we are examining here? So similarly, do it for all features one by one. So do one thing now. Ameya, you do it for half of the features. Kshitij will do it for half of the features. So that will consume less time.
Yes
okay
sir.
Kshitij, you do it by by
From
number
skewness
30.
onwards.
Yeah.
7 to 12.
chalega. You do it from range. How? Even skewness under bhi chalega. Just do it and then let me know the accuracy. You just write it on your Excel sheet and then we will exchange.
Yes sir.
बरोबर आहे. मेहनत तर तुला चेक करायचं असेल तर वरती जा आणि फीचरचं नाव बघ कुठलं आहे.
हो.
वरती दिसतं आपल्याला ना की किती फीचर कॉन्ट्रीब्युट केलेलं आहे.
हा हा right. हो स्टँडर्ड डिव्हिएशन अँड कंडिशन ठीक आहे.
हा बरोबर. डबल क्लिक करायचं म्हणजे ऑटोमॅटिक ते तेवढ्या साईज घेतं ते. तू जे हाताने मॅन्युअली पुढे करतो ना त्याच्याऐवजी तिथे डबल क्लिक करायचं म्हणजे ते ऑटोमॅटिकली त्याचा शेप घेतं.
अच्छा,
करून
okay.
बघ. डबल क्लिक कर तिथे एच्या शेजारी ना जिथे तू ते हे करतो ना वरती एच्या शेजारी जा. त्या सेलला हे कर. एच्या शेजारी
कुठल्या
ये इकडे राईट हँड साईडला ये. जिथे तू ते सरकवतो ना हा तिथे ते चल वर घे अजून थोडस. अजून वर घे. हा वर घे. हा तिथे डबल क्लिक कर. येस डबल क्लिक. हा कळलं का?
अच्छा हा कळलं.
तसं बी ला पण कर.
हो
तिकडे आता तिथे या साईडला नाही राईट साईडला आता राईट. हा येस.
ओके.
हे मुलांना मी एक्सेल एनएमसीपी मध्ये शिकवतो कारण मी एक्सेल वरती पण प्रोग्राम घेतो काही. तेव्हा या सगळ्या गोष्टी त्यांना शिकायला मिळतात. नाही तर हे पण नसतं माहिती बऱ्याच वेळा कारण कधी आपण एवढं वापरत नाही एक्सेल ना म्हणून. एक्सेल पण खूप चांगली प्रोग्रामिंग लँग्वेज आहे बरं का. म्हणजे एक्सेल मध्ये पण खूप चांगलं प्रोग्रामिंग करता येतं. या नाव कर्टॉसिस. Yeah, sample variance and then kurtosis. Yes. Kshitiz, you are done?
Sir, I am doing for some.
Okay, fine.
Sir, same values are coming. So
ठीक आहे ना काही हरकत नाही. आता खरं तर स्टँडर्ड डेव्हिएशन आणि सॅम्पल व्हेरियन्स आणि स्टँडर्ड डेव्हिएशन जर बघितलं तर आपण काय बघितलं फॉर्म्युला परवा.
हा राईट स्क्वेअर.
त्याच्यामध्ये फरक नाही पडणार. बोथ आर सेम ओनली. तसं बघायला गेलं तर व्हॅल्यू जर बघितल्या तर नुसते आकडे बघितले तर न्यूमरिकली. चला पुढे. Now kurtosis is remaining.
Yes.
How much is the value?
$26.67.
Yeah. So now take all the values, remaining values from Kshitiz.
Yes, sir.
Till that time, just select standard error again. Only standard error. Delete all other features. Find out classification accuracy. And then classify, start. Now select the last tree, J48, in the result list. Go to result list. Last one.
Yeah.
Right click, say visualize tree.
Okay.
Yes. Now Amey and Kshitiz and Aditya, tell me, what do you observe? Now here you will be able to understand the working of decision tree in depth. What do you observe here?
So there is only standard error because only that.
So in the
there is-
decision tree, only one feature is used because that feature has been floated there in the input. So all the classes will be classified only with respect to
Standard error.
standard error. So now if you see here, if standard error is less than or equal to 0.142599, then again the standard error will be classified as standard error itself. And again, if that value is less than or equal to 0.070575, then 21 samples are classified as good condition. Okay, fine.
Sir,
Yes, sir.
but there is a problem. When I was doing for a count, when I classified it, I was getting the same error, all those question marks, and the accuracy was
Yeah,
16.67%,
yeah,
abnormally low.
I'll tell you why is it happening. Now go to that result. अमे तू कर रही थे काउंट सा
sir.
कर सांगता अगदी सोपं आहे कारण काउंट ऑफ ऑल द सॅम्पल्स इज सेम ना इट इज 100 ओनली
अच्छा, ओके.
काउंट ठेव फक्त आणि बाकी सगळं डिलीट कर बिकॉज नंबर ऑफ सॅम्पल्स considered for each data points considered for each sample is same ना 100 इसलिए
Sir,
वो
but
that
for skewness also I got accuracy 35.33%.
that is fine, no? The, 35 you might be getting it because so what is the problem?
Because remaining values are uh, relatively higher than that. Because
हाँ ठीक है ना. Now come scroll down. So here you will see that all samples. Now here you will understand that training data has been like the data has been trained with respect to sequence as A, B, C, D, E, F itself. Why? Because all samples of B, C, D, E, F are misclassified as A. Amey Kshitiz, समजते का मी काय
yes,
म्हणतो?
sir.
Yes,
इथे
because
तुम्हाला
Yes, sir.
here you will
number is-
understand the meaning of misclassification. Now here if you change the sequence, then obviously the misclassification column will be different. It will be misclassified with respect to the feature which with respect to the class which has been displayed at the first stage. I mean, or we can say in the beginning.
Okay. Yes, sir. Yes, sir.
Okay, so that is why the accuracy is lowest for count, which is 16 point something.
Yes.
Okay, so this was all about the individual feature and its contribution for the accuracy. So if you select individual feature, you might. So now tell me which feature gives you highest accuracy. Go to the Excel sheet, Ameya. लिही रे
So the
ह्याच्याकडून
highest I got for minimum was
skewness लिही.
77%.
Kshitiz, just tell all the results.
Yes, sir. Skewness 35.33. Range 68.33. 68.33. Minimum 77.
Yes.
Maximum 57.33.
Let it be.
Okay.
Chal.
Maximum
57.33. Sum 70.67. Count 16.67.
Yeah, that's it. So now you can rearrange this with respect to ascending or descending order.
Okay, sir.
Now before that, no. Add one more row before first row.
Before
Standard
first.
error.
Okay.
हाँ एक रो ऍड कर.
Hmm.
तिथे लिही फीचर आणि इकडे लिही अॅक्युरसी.
Okay.
Yeah, so now click on accuracy. Go to filter.
Yes.
No, not that one. Yeah, correct. Filter, yes. Come to filter again. No. Filter, yeah. And then click on that accuracy ka yes. And then say smallest to largest to smallest. This is the easy method to rearrange all the same. Remember this, yeah. So now you get all this features with respect to highest accuracy to the lowest accuracy. So we can say we have we have done the ranking of feature with respect to accuracy. So rank 1 feature will be
Minimum.
And less will be the least will be count.
Count.
Okay. So now after this, here we have done calculated the accuracy, or we have found out the accuracy for individual feature. Now after this we have to do it now, because see, if you see here that if you select only minimum, then you get accuracy as 77. But the accuracy when all the features were selected and J48 algorithm was deployed, the accuracy was how much? 89. Na? How much it was? So when we consider all the features.
Sir, it was 89.6.
89.6.
Yeah. So that means if you consider combination of various features, then you might get the highest accuracy. Okay. So now what you have to do is you have to again just go to that result list, last result, right click, visualize tree. Yeah. So now what you have to do is you just write the features which has been exhibited in the decision tree. Now I'll tell you what you have to do. Kshitiz,
Yes, sir.
you just read the name of features which has been displayed here in the tree, and Ameya, you just write it in the Excel sheet. Start from summation. Ameya, go to Excel sheet. Kshitiz will tell you all the features. कौन कौन से फीचर्स इसमें दिखते हैं, राइट वन बाय वन. तिथे लिही, पुढे लिहिलं तरी चालेल.
एक बार वो फिर से स्क्रीन खोल, मैं स्क्रीनशॉट ले लेता हूँ.
अच्छा, तेरे पास नहीं है क्या?
सर मैंने ये वाला अभी नहीं खोल रखा है.
तो डू इट ना.
ठीक है सर, हो गया अभी.
हाँ.
सर तो मुझे क्या करना है, पहले सम बोल के फिर
सम
मैक्सिमम
बोलो, फिर
मिनिमम.
मैक्सिमम वैल्यू. या जो भी दिख रहा है इधर फीचर्स, वो सब फीचर्स बताओ.
तो मैं एक लेग पूरा फॉलो करूं ट्री का कि
ऐसा कुछ नहीं,
सब
कैसे भी हो,
बताओ.
सब
ओके
पता.
ठीक
हाँ,
है.
बस.
सबसे पहले सम, फिर मैक्सिमम मिनिमम. हाँ मतलब अब वो ट्री बन गया तो एक के नीचे
नहीं,
लिखा तो
खाली
चलेगा.
खाली काही प्रॉब्लेम नहीं. अरे हियर जस्ट वी आर जस्ट राइटिंग व्हिच फीचर्स हैज बीन यूज्ड फॉर फाइंडिंग आउट द एक्यूरेसी. क्योंकि डिसीजन ट्री सब फीचर्स यूज नहीं करता. जितने सिग्निफिकेंट फीचर उसको लगते हैं, मतलब विथ रिस्पेक्ट टू एंट्रोपी रिडक्शन एंड इंफॉर्मेशन गेन. सी बेसिकली J48 tree works on the principle of entropy reduction and information gain. That means it reduces the entropy. मतलब randomness जो होता है amongst the various classes, वो reduce करता है. And with respect to that, it selects the feature. ऐसा.
Okay.
So it
उसके
won't
बाद
select
रेंज.
all features. It will select
Okay.
only significant features which will give you the combination of which will give the highest accuracy. ऐसा.
Okay. ठीक है फिर मिनिमम के बाद रेंज. सर जो रिपीट हो रहा है उसको इग्नोर करूँ ना कि फिर से बोलूं?
हाँ, ignore. Yes, yes, yes.
मीडियन. एक मिनट. स्क्यूनेस. कर्टोसिस. स्टैंडर्ड एरर. ठीक है हो गया इतना ही है बस. बाकी रिपीट है.
So now, yeah. So now, the thing is, you might say that, ठीक है, either now we will compare the first table and these features which has been used by decision tree. Okay. So now here in the rank, the minimum feature, the feature minimum has been ranked 1. तो इधर है क्या वो देखो है. It has been used. तो कुछ लॉजिक समझ में आ रहा है, मतलब हम बोल सकते हैं कि कुछ लॉजिक है. देन समेशन है क्या है.
Yes.
रेंज है क्या है. स्टैंडर्ड एरर भी है. नाउ स्टैंडर्ड डेविएशन इज मिसिंग, वेरिएंस इज मिसिंग, मीडियन इज देयर, maximum value is there, mode is not there, skewness is not, yes, skewness is there, kurtosis is also there, and count is not there. So you might ask me question that skewness, kurtosis has very low accuracy individually, but when we are considering combination, it has been considered. Why is it happening? Are you getting my question?
Yes. Yes, sir.
You might
Yes,
ask
sir.
question that combination of such features must be considered which gives accuracy more than 50%, na? So minimum, sum, range, standard error, standard deviation, variance, median, maximum value. इतने फीचर यूज करके देख सकते हैं हम, क्योंकि इंडिविजुअली ये सब बहुत अच्छे कंट्रीब्यूट कर रहे हैं, ऐसा आप पूछ सकते हैं ना. तो why is
Yes,
skewness
sir.
and kurtosis is added though it is giving less accuracy? तो उसका मीनिंग ऐसा है कि when we are considering the combination of features, then the skewness and kurtosis give 35 and 26% of accuracy respectively. But it might happen that the accuracy of 35% which is given by skewness and the accuracy 26% which is given by kurtosis might be distinctive than the accuracies which are given by other features. That means the accuracy which is given, 35% accuracy which is given by skewness will be only given by skewness. It is unique accuracy. Are you getting what I am saying?
Yes.
Or kurtosis. The 26% of classification which has been identified by kurtosis will be only identified by kurtosis itself. It might not be identified with respect to other features. See, if you consider first feature, minimum feature, what is the accuracy?
77%.
So there 23% accuracy is missing. So that 23% accuracy might be given by
Skewness and kurtosis.
yes. So that means manual accuracy or this manual feature selection is not logical. What we have done. We have just tried to find out the contribution of individual feature. But that contribution of individual feature may not give you highest accuracy. That is why combination of features must be considered. But then you must ask me question how to find out this combination. So
Yes,
this
sir.
is done. This is done using various techniques. One of which is decision tree. So that means the features which has been exhibited in the decision tree are considered to be most significant features, and only those features are selected to get the highest accuracy. समझ में आ रहा है क्या? This is the first method, very basic and simple method which is used for feature selection. समझ में आ रहा है? So in the
Yes.
machine learning, first step is signal acquisition, second step is feature extraction. जो हमने ट्रेनिंग डेटा सेट तैयार किया है उसको फीचर एक्सट्रैक्शन बोलते हैं. Now feature selection will be this thing which just now I taught.
ओके.
There are
तो
there are many
मतलब हम
techniques.
न्यू डेटा लेंगे तो सिर्फ ये वाले जो फीचर सिलेक्टेड है वो उन पे फोकस करेंगे.
Yes, correct, very correct.
ओके ओके.
Not new data, but the same classes, new data for same classes. It is assumed that input conditions or boundary condition we can say for which the data has been acquired are considered for training data. Then only this will work. If you see, if you change input parameters, boundary condition, then obviously it will change, na? Because this complete machine learning is depends on the data which has been acquired initially and has been trained. और उसके सिमिलर ही आता है कुछ डेटा तो भी तो then and then only it will be able to classify and predict. Fine. Yeah. So now what you have to do is you again go to Weka. Go to result list. त्याच्या खाली क्लिक कर ओपन स्पेस मध्ये आणि ते सगळं डिलीट करून टाक. राईट क्लिक. ओके. क्लिअर रिझल्ट्स आहे असेल ना? कुठं नाहीये का? ओ सॉरी ते मॅटलॅब मध्ये असतं. ते एक एक सिलेक्ट करून आहे का? हा ठीक आहे, होत असेल तर बघ. हा ठीक आहे.
डिलीट रिझल्ट्स बफर.
हा ठीक आहे. आता गो टू प्री प्रोसेस अगेन. ओपन फाईल. परत फाईल ओपन कर. हा आता नाउ व्हॉट यू हॅव टू डू इज यू हॅव टू कीप द फीचर्स ओनली विच आर एक्झिबिटेड बाय डिसिजन ट्री. डिलीट अदर फीचर्स. स्टँडर्ड एरर आहे का? आहे का? आहे, राहू देत. मीडियन आहे का? नाही आहे. डिलीट. मीडियन आहे, ओके. मोड नाही आहे. पुढे
स्टँडर्ड डिव्हिएशन नाही आहे. सॅम्पल
कर्टोसिस आहे, स्क्यूनेस आहे, रेंज आहे, मिनिमम आहे, मॅक्सिमम आहे, काउंट आहे. हा रिमूव्ह अँड नाव सी द ॲक्युरसी. क्लासिफाय स्टार्ट. किती येते ॲक्युरसी सांगा?
हायेस्ट ॲक्युरसी 89.
मगाशी किती होती सगळे फीचर सिलेक्ट केल्यावर?
हीच होती सर.
हा ठीक आहे. सो दॅट मीन्स देर इज नो चेंज. अभी नाउ आई विल प्रूव दिस. I will prove this. Now you might ask question कि सब फीचर लेने के बाद और इतने only these features, only if we select only this much of feature, there is no change in the accuracy. I will prove this now. Okay. So now what you have to do is again go to pre-process. Now only keep summation. राहू दे, हेच फाईल राहू दे, बाकी सगळं डिलीट कर. Yes, which was the feature exhibited at top in the decision tree? Summation, na?
नहीं, minimum.
No, it was summation.
अच्छा, the top of the tree. Okay.
Yeah, topmost feature. It is considered as the significant feature for decision tree. Yeah. So only keep some. Yeah, and remove. Anyways, but we know the accuracy for some, so don't do it. Just write it there. Yeah. So we know it. Just write it there. Summation च्या पुढे लिही तिथे. Yeah, just write it there. किती आहे? 70.67.
Sir, but why is some significant?
According to decision tree. So what the decision tree will do is it will go through all the features and all the classes, and then it will try to identify which will be significant feature according to the randomness. So that means if it is giving or if it is exhibiting the randomness, with respect to the particular class. See, if it considered class A, and if the randomness of that particular class is highest for summation, then it will select summation. It might not select the minimum, because here it will depend, completely depends on how the randomness for each particular feature has been described by that particular feature.
Okay.
Okay.
Now, yeah. So now what you do, again go to Weka. Pre-process, upload the new file. Now keep only summation and maximum value. Or you can keep minimum also. We have to add one by one feature. Just wait. Summation and maximum or minimum. एक काहीतरी ठेव.
Okay.
Maximum ठेव. हाँ. Remove. So now here what we are doing, wait. What we are doing is we are trying to find out combination of maximum and summation, or contribution of maximum and summation together on the classification accuracy. So when we are using two features as maximum and summation, what will be the accuracy? Go to classify. किती आलं? See, 80.33. So now I write it there. आता तिथे मॅक्सिमम
Sir,
त्याच्या खाली नाही 70च्या खाली मॅक्सिमम लिही. उचल ते इकडे पेस्ट कर.
काय सर?
मॅक्सिमम इकडे पेस्ट कर. 70च्या खाली मॅक्सिमम पेस्ट कर. उचल मॅक्सिमम.
हा ओके सर. मॅक्सिमम इथं लिहू का?
ठीक आहे. आता इकडचं मॅक्सिमम डिलीट कर आणि समेशन लिही तिथे खाली मॅक्सिममच्या जागेवर.
हा ओके.
कळलं ना? जस्ट अ मिनिट. हा तिथे अॅक्युरसी लिही 80.33. बोल रे क्षितिज.
Sir, but ideally the classifier has already done this, right? So it has finally found out that this whole combination will give the maximum. So all the combinations that we try will always be less.
No. Why I'm doing it? Because I want to prove that कि इसके बाद अगर if you add any feature, then there won't be change in the accuracy. It will remain same, or it will increase. I mean decrease. Sorry. So these are the minimum number of features which must be used. क्योंकि when you are using this much of features and when you are using all features, accuracy is same, na?
Yes, sir.
So if you want to see the time required, if you see the time required when all features are used, and time required only when only few features are used, it is different. Time required to build the model. ते दाखवतो. वेका उघड रे. Go to performance result. हे तिथे आहे बघा. इथेच दिलंय. Time taken to build the model 0 seconds, which is very less. Because J48 is the very basic tree, it consumes very negligible time. But time which is required when all features is considered might be more than this one. It might be 0.01 seconds. So when you have used data, Kshitiz, when you have suppose 1 lakh samples, then obviously the time will matter, na? Time which is required to build the model will matter, right? So that is why features are selected. Because if you select less number of features and if you are getting good accuracy, then those features are preferred. Not all features are preferred, because then time required for analyzing less features and getting maximum accuracy will be desired, na?
Okay.
समझ में आ रहा है?
Okay, sir, but if our training data is smaller than the test data, then the accuracy will be less, right?
This is not allowed actually. This is the drawback of traditional machine learning algorithms. The training data must be bigger than the test data.
Okay.
But to eliminate this limitation, we go for predicting blind data set. The data set which does not have any class, which is not known actually. There you can feed n number of data. That I will teach you in the next class. Blind data sets का
Okay.
classification. Even this one, test इधर test options में training data set इधर लिखा है ना, use training set, supplied test set, cross
Yes,
validation
sir.
and percentage split. उसमें से मैंने सिर्फ क्रॉस वैलिडेशन सिखाया है अभी तक. नेक्स्ट क्लास में हम ट्रेनिंग सेट, टेस्ट सेट, परसेंटेज स्प्लिट एंड ब्लाइंड डेटा सेट ये सब सीखेंगे. ठीक
Okay,
है,
okay.
तो जस्ट
Yes,
यू
sir.
जस्ट डू दिस प्रोसीजर.
So now then I will take three parameters.
Yeah.
Some maximum
Summation,
and minimum.
maximum and minimum. I just a minute. I hope you both have you're done with your food.
Yes,
Yes,
sir.
sir.
Yes. Yes.
हाँ ठीक
No problem.
ठीक है. Then go ahead. Yes, 85.
85.
मिनिमम तिकडे शिफ्ट कर. ठीक आहे, टाइप कर. ठीक आहे, मिनिमम. एक काम कर आणि आता टेबल अख्खा लिहून घे आणि नंतर मग अॅक्युरसी काढत बघ. 85. या
Okay, sir. ठीक.
आता ते कॉपी पेस्ट कर, फक्त रेंज तिकडे उचलून शिफ्ट कर
हो, sir.
85 ला. तसं नाही करायचं, तसं नाही करायचं. थांब 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 थांब.
अच्छा,
कंट्रोल
कंट्रोल C कर.
नाही 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 नाही, सांगतो तुला, शिकवतो, थांब जरा.
हा,
कर
sir.
ते, डिलीट कर. इकडचं रेंज डिलीट कर, सांगतो तुला मी काय करायचं. डिलीट कर. नाही ते नाही, इकडचं कर. तुला मी
Okay,
शिकवतो
sir.
कसं कॉपी पेस्ट करायचं. हा, शिफ्ट कसं करायचं शिकवतो. जा त्या रेंज वर क्लिक कर. हा, आता त्या कोपऱ्यात ये. नाही नाही, कोपऱ्यात नको, वर जा, थोडस वर. हा, उचल, ड्रॅग कर, जस्ट ड्रॅग इट.
हा, ठीक आहे.
हा, कळलं का?
हो.
हा, आता ते वरचं घे, तिन्ही कॉपी कर. तर
हा.
मॅक्सिमम मिनिमम कॉपी कर.
हो, sir.
ते वरचं, हा, कॉपी कर तिन्ही आणि ड्रॅग कर खाली. बस. मीडियन तिकडे तिकडे हे कर.
हो, sir.
ड्रॅग, करेक्ट. व्हेरी गुड. चला. Kshitij, you do it for some of the combinations till that time.
Yes, sir. I'll start from the bottom, from the second last one.
That we know, na?
So last one we know. I'll start from the
Yeah.
second last.
Yeah.
हमें एक मिनट वो एक्सेल शीट खोलना, ये वाली. एक सेकंड बस.
हाँ.
हाँ बस ठीक है. सेकंड लास्ट वाले का 87.33.
लिही तिथे.
87.33.
Yes. So now after this
89.67.
लिही तिथे किती आहे तिथे.
89.67.
Now after this, select last combination and add any of the remaining feature. You will find either it will decrease or it will remain same. You take one combination, you take another combination. Which features are remaining? Standard deviation and variance is not there. So you take standard deviation, Amey, you take variance, Kshitiz, to the last
Yes.
combination. Add it.
Okay, sir. Fine. Okay, I'll take standard deviation.
Open file again.
Standard error is there, so
Mode is not there. Sample variance is not there. Kurtosis range is there. Sum is there. Everything. Count is not there. Yeah. नाही रे काहीतरी चुकतंय. थांब.
Sir, what am I choosing?
standard error आहे sir. Some
किती आहेत हे
maximum
फीचर? लास्ट कॉम्बिनेशन मध्ये किती फीचर आहेत?
last 8 features.
8 आहेत ना, मग इथे 9 यायला पाहिजे. नाही बरोबर आहे. चल
10
बरोबर
condition.
कारण कंडिशन आहे. चल क्लासिफाय. But there is no change.
Okay.
Yes. So that means if your decision tree selects the best combination, उसके बाद आप कितने भी feature add करो, that will be treated as irrelevant features and the accuracy won't change क्योंकि वो consider ही नहीं करता. Though it is considered in the test, but decision tree will not be considered it. So and even if it considered, then the accuracy will reduce ऐसा. तो किती आला क्षितिजचं?
Sir, which one was I calculating? I didn't understand.
क्या?
सर मैं कौन सा वाला फीचर एक्स्ट्रा ले रहा था?
अच्छा छोड़. तू आता ह्याच्यात ऍड कर रे व्हेरियंट्स.
Variance. ओके ह्यालाच हो सर.
हा ते परत करायला लागेल म्हणजे फाईल.
हो सर.
आदित्य बोर झाला असेल. बिकॉज टुडेज सेशन वॉज कम्प्लिटली हँड्स ऑन सेशन. बिकॉज सगळे बेसिक फंडामेंटल आधी शिकवलंय या पोरांना, त्याच्यामुळे त्यांना माहिती आहे सगळं.
नाही सर थोडं कळतंय. तिचं करून टाकीन. इन्स्टॉल करायला लावलंय.
काही नाही लावलंय ना. व्हेरी गुड. ती फाईल त्याला शेअर करून दे रे आम्ही नंतर एक्सेल आपली. सी हियर 89.66 रिमेन सेम.
येस सर.
So now leave it. मला माहिती आहे ते सेमच राहतं, ते काही फरक पडत नाही. So the first table which we generated is called as effect of individual feature on classification accuracy, and second one is considered as effect of number of features or effect of combination of features on classification accuracy. ठीक है.
Yes, sir.
Okay.
Yes.
So now I will give you. I'll try. Just go to CSV file. Open CSV file. Our CSV file. Now close Weka. Save this Excel sheet as results.
Yes, sir. So now I'll open the
CSV file.
Excel file. Yeah, okay, sir.
That one. X final.
Right.
Weka बंद करून टाक सगळं. ट्री पण बंद कर.
Oh, sir. Sir,
So now my question is assignment for tomorrow. My question is the sequence in which the statistical features are written. Do it matter the performance, or if you change the sequence of statistical feature, will the performance change?
okay.
This is my question. Okay.
Okay, sir.
कळलं का क्षितिज क्वेश्चन कळलं का?
Yes, sir, but sir, I think in the start we discussed, right, that the order matters.
That order we discuss for condition samples कि गुड पहले रखना है क्या फ्लैंक वेयर रखना है क्या क्या
अच्छा,
रखना
ओके, राइट.
क्योंकि अगर तू फ्लैंक वेयर रखता है तो उसके नीचे वो 50-50 आता फिर.
Okay, sir, but I think for this one it should not matter because the for example the chaos in the values will remain the same, be it first or at the end.
So that you have to answer me tomorrow. You have to study and answer.
Okay.
Okay, I'll
Okay,
give
sir.
you another hint. Tell me feature which has been exhibited at top of the decision tree. कौन सा था?
Summation.
And the feature which we individually we selected. Then which feature was at top?
Minimum.
So here minimum is given in the. It is written before the summation.
Okay.
So I just want answer from you guys tomorrow that ये feature का जो sequence हम रखते हैं, does it, I mean, will it matter the performance of classifier? The sequence in which the features are written. क्योंकि sample का तो हमने देखा कि condition का sequence आप change करते हो तो there will be change in the performance of the configure matrix.
Yes, sir.
Similarly features का भी कुछ sequence है क्या, अगर वो हम change करते हैं तो क्या change होगा, ये मुझे कल बताओ. ठीक है?
Okay, sir.
Now
Okay,
if you have
ठीक
any
है.
doubts till this, you can ask me, otherwise we will resume tomorrow.
Okay, sir. Sir, tomorrow also at 9 o'clock.
You tell me time. Usually मुझे कॉलेज होता है पूरा दिन भर, तो मैं 7 बजे घर आता हूँ, 7 साढ़े 7 बजे. तो उसके बाद खाना खा के थोड़ा सा रिलैक्स होके देन